Now in this lecture, we shall learn that how we can define the load combinations that we shall be using for the this particular mezzanine floor structure. So first of all, if we want to see the the codal provision that is given in the code, so you do need to refer to AS 1170 part 0, and in this particular code we can say that we have to refer to the strength design load combinations. And in the strength design load combinations, you can see that the first load combination that we have to follow is 1.35 times the G, that is the 1.35 times the permanent action, or we can say the dead load also. Now, the second load combination that we do need to implement is 1.2 times G, that is permanent action, plus 1.5 times Q, that is the imposed actions. The third one is that instead of imposed, we are thinking about the long-term imposed action. So for long-term imposed action, you shall see that both of these values are same, except that in this particular case, we have added psi L also here. So for the value of that, we do need to refer to this particular long-term factor. So in our case, we know that mezzanine floor shall be used for the storage. So in that case, this value becomes 0.6. So 0.6 multiplied with 1.5 becomes 0.9. The fourth load combination is 1.2 times the permanent action plus W. W is basically the wind, but as in our case, this is inside the structure, so we do not need to take any kind of wind. And additionally, we have to multiply it with the psi C and Q, that is the imposed action. Now, this psi C is basically the combination factor, and in our case, it again becomes 0.6 as this is a storage structure. So after that, the fourth load combination is again the 0.9 times the permanent plus W, that is the imposed action. So this produces the maximum bending moment on the columns because it produces the maximum, we can say, overturning effect on the building structure. So in our case, we don't need to use this, as this we are not considering any kind of wind, as this is inside the structure. After that, this is G plus E plus psi EQ. Now G is basically the permanent action. We know that that is basically the 1 times earthquake EU, that is again 1, and imposed, this is again needs to be multiplied with psi E, that is earthquake combination factor. So in the case of storage structures, this becomes 0.6, and in all the remaining parts or all the remaining cases, it becomes 0.3. Either it is retail, parking, offices, or residential and domestic. So, and in case where you're not sure about what exactly shall be the storage purpose, or sorry, what is officially the purpose of that particular floor, we can simply take maximum value, that is 0.6. So after that, the next one is the 1.2 times dead plus SU is basically the snow, and psi CQ, that is basically the imposed action multiplied with the combination factor, that is psi C. So we are we do have now information that we do need to do use this particular case 1.35 times dead, 1.2 times the permanent plus 1.5 times the imposed, 1 the 1 times permanent plus 1 time earthquake plus multiplied with 0.6 times the imposed action. So now we can open the ETABS. Now to define the ETABS, basically to define the the load combination, we do need to refer to this particular case, that is define load combination. Now in this particular window, we do have two options. Either we can use the add new combo, or we can use add default design combos. So here we do have an option that we can use the steel frame design and convert to user combination editable. But before that, we do need to ensure that under the steel frame design and view revise preference, we do have selected AS4100, because if it is AISC 360, then it shall add the American design load combination. So we can again go to the load combinations option here, and we can add default design combos, convert to user combination, and select steel frame design. Left click on OK. There's one more thing that we do need to confirm. We do know that this is an we can say EDC2 category, that is earthquake design category 2. And in this particular case, we do have discussion in the earlier lecture that we do have to use the 100% of horizontal earthquake force for one direction and 30% in the perpendicular direction. So this basically option is not by default implemented in the ETABS. So first of all, let us just start with this particular option, that is D1, D2, and after that you can see S1, S2. Now for D1, D2, basically what they are doing is that they are following the this serviceability load combinations. So combination of actions for serviceability limit state, basically this is that we do need to, uh, use the appropriate combination may include one or number of following use cases using the short term and long term values given in table 4.1. So short term and long term values are these particular, values that we have already discussed. And we do need to, consider the 100% of permanent action, that is one only. Psi SQ, that is the imposed action multiplied with the short term and long term. Here we do have psi S as storage as 1, and then again for long term we do have 0.6. So it should be, one time permanent plus one time imposed, one time permanent plus 0.6 time imposed, considering that here we have to use the psi L, that is the long term, factor. After that we do have wind, and after that we do have ES, that is the earthquake. So that is the, criteria to determine the serviceability limit state load combination. So here, if we left click on this modify show combo, we can see that ETABS has by default generated a load combination with only the dead load option, that is dead load and SIDL. Both of them when added makes us the total value for the permanent, we can say imposed load. So here we can add one time 0 DL plus SIDL. So we can left click on OK. And after that, the second one is that we do have added the live load also. Now in this particular case, we can say that we have not added the just a minute, one time dead load plus live load. I shall use the live load and action, interchangeably, because both of them means the same thing. So one time dead load plus live load plus SIDL. Now in this case, the code is saying that either you can use the short term combination factor psi S, which was 1, or you can use the psi L, that is 0.6 for the long term combination factor. And obviously, in this particular case, the short term factor shall obviously govern the design. So we can left click on OK. And these two are the, we can say, serviceability load combination. So what we can do is that we can left click on add new combo, and here instead of combination type we can add envelope, and we can add here as serviceability, and here we can add this one time dead load plus SIDL, and then again one time dead load plus live load plus SIDL. So these two are the serviceability load combination, and it is always better that you can add the envelope, otherwise you have to manually select each and every load combination when you should be checking the results. So after that, we can left click on this particular option. So here you can see that it is just 1.35 times the permanent action. So we can add 1.35 times the G, or we can say 1.35 times the dead itself. So now it is clear, and after that the second load combination is this particular one, that is 1.2 times permanent, or that is dead load, plus 1.5 times the imposed action, that is live load. So this is also okay, and 1.2 permanent plus 1.5 imposed. So this is the basic load combination. Here you can see that 1.2 times G plus 1.5 times Q. So we can left click on OK here, and after that the third load combination is, now it is mixed with the earthquake load also. But when considering the earthquake load, the factor also becomes 1, and other factors, that is the dead load, also becomes 1, and live load instead of 0.3, as we are using this for the storage application, we have to change it to 0.6. Now there is one more thing that you do need to understand, that when we are considering the ELX, we also have to consider the 30% of ELY. So we have to add 0.3 here. So now we can say that our the load combination become 1 time dead load plus 0.6 time live load plus 1 time ELX plus zero point 0.3 times ELY. So this is the load combination that has to be used as per the code only. That is this particular one. 1 times the dead plus 1 times the earthquake plus psi e times q. So psi e in our case was basically earthquake combination factor, which for storage becomes 0.6. So that is the one that has been used here. Now we do have we can just press Ctrl C option on a keyboard, left click on OK, and then left click on add copy of combo, and then again press Ctrl V. Here instead of plus 0.3 ELY, we can add minus 0.3 times ELY because everything else is same. So we can add minus 0.3 here, left click on OK, and then again we can say left click on add copy of combo and plus plus. Now you can add minus plus. This is minus ELX plus 0.3 times ELY. So we can add here minus and plus, because we have used plus 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 minus, and now we are using minus and plus, and then we shall be again adding here as minus and minus. So here also we shall be using -1, and here also you shall be using minus sign here. So now we have added the dead load plus 0.6 times the live load plus the earthquake load combination factor. Now we can check other factors also. So here also it is using minus. So we can simply delete this because we have already used it here. And then again we can check this particular load combination. Here we are using ELY as 1. And what we do need to do here is that now we can left click on modify show combo here, and instead of now ELX as the first term, we do need to use ELY as the first term and ELX as the second term. And here we can just add here and ELY plus ELX, and now ELX shall be 0.3 in all the combination factor. We can press Ctrl C option here by selecting this, and we can everything is okay, and just for live load here we can add 0.6 here. Now we can again do the same process here with add copy of combo. So ELY minus 0.3 ELX, and then again we can left click on add copy of combo. Now we have used plus plus minus. Now we have to use the minus and plus. Here we have to use minus and plus, and then again we have to left click on add copy of combo, and then all the terms shall be minus and minus. Yeah, so now it is okay. So now we have added the all possibilities of the load combination where we were using dead load, live load, and earthquake load along all the directions. So ELX and 30% of ELY makes 4 load combination. ELY plus 30% of X makes 4 load combination, because we have to use plus minus interchangeably. So now it is done, and after that we can check UD this particular case also. We have already corrected this, so we can delete this. Again we can, yeah. So now this is the load combination where we have skipped any kind of storage application on the top, because it shall add to the maximum overturning effect on the structure. So it may be a case where there is no as such live load on the top and the structure is free to sway. So we have to check the stability of the structure or strength design of the structure for that possibility also. So we can just simply add 1 times dead load plus 0.3 times ELX, sorry, plus 1 times ELX plus 0.3 times ELY. So we can add here ELX and ELYS 0.3. Now you do need to understand that there's no as such live load here, so we are not using any kind of load combination factor, because dead load is dead load, but live load, due to its variation or probability that it may happen, or it may be there, it may not be there, we have to use the combination factors. So we can select and press Ctrl C option on a keyboard, left click on OK, and then again left click on add copy of combo. Here, we can add ELX minus 0.3 times ELY. Here we can add minus. And then again, left click on add copy of combo. Now we have to use plus, 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 minus. Now we have to use minus and plus. Minus and this shall be plus. And again, we have to left click on add copy of combo. And now all the factors shall be minus only. So we can left click on OK now. And after that, we are left with these load combination. We can just simply delete this because we have already corrected this load combination. And then again, we have also corrected this load combination also. So now we can add, we can say strength designed load combination factor also. So what we can do here is that we can left click on add new combo, and we can add strength design load combination factors here, and combination type, it has to be envelope. This may be done or this may not be done, but trust me, this shall make your calculation process a lot easier. So it is not that all of these combinations are added, it is just an envelope. So scale factor, basically it doesn't matter here. So now we can select all the strength design load combinations here. There is an easy way also of adding this, that also I shall be discussing with you very shortly. But just as if you are using this software for the first time, then it is essential to stick to the basics, because that is a little bit of a, we can say, a somewhat little bit more technical. So we have added plus minus here, and then we have to add minus plus, and then we have to add minus minus, and then we have to add these three load combinations here. So now we have added the strength designed load combination envelope also. We can left click on OK, and then again left click on OK, and we can just simply save this. So now our load combination factors are defined. The option that I was discussing with you earlier was under the edit option, we do have an interactive database option also. So that is an option which help us in saving time if you have some practice of the software. So we can add under the load case definition, we do have load combination definition also. We can left click on OK. So now under this, you can see all the various type of load combination factors that has been added. And what you can do, we can simply manually change this also. So whatever changes we shall be doing here, that shall automatically be, we can say, done in the model. So either we can export that to the Excel also. So what we can do, we can left click on the send table to Excel option, So now here you can see that all the load combinations have been exported to the Excel, and whatever the changes we shall be doing here, that shall there's an option in which we can simply export those changes to the Excel also. So just as a, we can say, practical experiment, instead of this, let us just say that I want to change it to 1.5. Let us just assume that this we have done to one time dead load plus live load plus SIDL. Here we have increased the dead load factor to 1.5. So now it is done, and then you can just simply click on this particular option, that is from Excel. So here you can see that how this factor which we had changed to 1.5 in the Excel has automatically be done here. And now just simply left click on apply to model. This is, we can say, a little bit uh, uh, an option that use we can say a little bit of more memory of a computer system. So we can left click on done here, and then again we can check that whether the changes that we have done in the Excel are done here or not. So we can left click on load combination, left click on this case, and left click on modify show combo here. So here you can see that how the 1.5 that we have changed in the Excel has now been done in the ETABS software itself. So we can again undo the changes, left click on OK, as this is a serviceability design load combination, and then again left click on OK. So after that we do have to define the mass source also. Now mass source is the, we can say, a seismic mass, because ultimately we have to tell the software that okay, for this particular case we have to take this much amount of the dead load and this much amount of the live load for the load combination or for the seismic load application. So we can change it to name, can change it to mass source. We can left click on specified load patterns and we can undo those. So we can left click on dead, and then again we can add for the live load factor, as we are using the storage application, we have to change it to 0.6, and then for SADL again we have to change it to 1. So the 100% of permanent action and 60% of the live load application, that has to be considered in the, we can say, mass source calculation. So we can left click on OK, and then again left click on OK. So now in our case, if we check, material properties are defined, section properties are defined, and diaphragm we can define considering that if it is we can say, if we are using the dynamic analysis, of we are applying some kind of load at the diaphragms. So we are not using the dynamic analysis, so we can restrict our calculation to mass source. Now for P delta option, either we can left click on based on mass, or we can left click on based on loads application also. So in our case, we do know that dead load, live load we can change it to 0.6, and SIDL we can change it to 1, and for ELX, now we are free to either choose the factor, we can change it to 1.2 also, or 1 also. So in this case I'm just adding both of these options as 1 here. So P delta option is required, as we are talking about a steel structure in which there are additional bending moment due to deflection at the top, and there are these like two types of P delta. Now there are two types of P delta classification. One is P capital delta, and this is known as P small delta. Now P delta is a case where let us say this is the cantilever column, and we are applying 5 kilonewton load on the top. Now when this particular steel column deforms, and let us say there is this 100 kilonewton load application also on the top. So let us say this gets deformed by 0.005 meter, or we can say 5 mm. Now this load application, which we have assumed as an ideal analysis, was coming here, it actually is coming here. So we can say that there is an additional bending moment that is generated, and that value is basically 100 kilonewton into 0.005. So this additional we can say bending moment that is generated at the top, that is considered only when we have tell the software that okay, we want to do the P delta analysis. Otherwise, whatever this number is coming, we can say approximately 0.5 kN meter. This bending moment shall get ignored if we have not switched on this P delta load combination factor. And in the cases where the height of the column is very high, we are talking about a slender structures, or we can say that the this horizontal force is also very high in many cases. Let us say we're talking about a structure in cyclonic areas where there are, we can say, cyclones. In that particular case, it is very important to consider the P delta analysis. Now, when we're talking about the P small delta, in many of the cases, it is by default assumed in the calculations in the formula in the code itself. But in many cases, we have to consider that also. So the basic concept of P small delta analysis is that, let us say this is the steel column. In many of the cases, it is not practical that there shall be, we can say, 100% straightness in this particular column. There may be a little bit of, we can say, slight deformation here, or we can say slight deformation here, which deformation may be in the range of, we can say, 2 mm, or here it may be get deformed by 4 mm, which might not be visible to the, we can say, your eyes only, but it is there because ultimately steel is a very slender structure and its principle is to get deformed. So to consider these kind of, we can say, local deformations, these are known as the local deformations. We have to use the P small delta analysis. So that is the basic concept, and ETABS has made our job very easier by making us an option that we can use the P delta either based on the mass or based on the loads. And as I said that it is always recommended that it is we should always be selecting iterative based on loads only. So if wind analysis must also be there, then we shall be adding the wind load cases here also. So we can left click on OK. And now we are done with, I think, all the possible load combinations. And then, in the next lecture, we shall be discussing much more about what needs to be done next now.